Okay, this is Michael Sheward, the reseller of Bequant, welcoming everybody to the webinar today. I appreciate everybody attending. We're gonna record this as well, so it's going to be available later if you want to come back and view it. I think that one of the reasons why we wanted to have this is that there have been a lot of improvements to the Bequant software offering. There's been a bunch of enhancements in the visibility side of the product as well as the DPI side of the product. Originally, many years ago, when it came to the US market, it was positioned as a TCP accelerator, but it's kind of morphed to be much more. Also has DDoS improvements and an API. So that API can be used to integrate with billing systems and other operational support systems. So having said all that, couple things. You can submit your questions. We'll answer them at the end. As well, if you're interested in a trial, then you need to contact me. My contact information will be on one of the slides here at the end. And with that, I'm going to turn it over to Jose Lopez, the president of Bequant, who's going to take us through the new features and the product itself. So, Jose, take it away.
Thanks, Mike, and thanks to all the attendees. Let's try to present all the new features and all the aspects of our product, where we basically have a product that can help you improve the quality and performance of your network. In particular, in what situations can we be of help if you have low or irregular speed tests at some times or with certain subscribers. If you have low video streaming quality or stalling, if you have any latency issues with online gaming, if you have any subscribers that may be using your network in an abusive way beyond the usage that you would expect from a normal user. If you don't have quality of experience or measurements for your subscribers, we can help you also. If you, or in any case, if you want to mitigate congestion or reduce internet bandwidth, we're also of help. As I said, basically, if you want to improve the quality of your network, if you want to improve the performance, we can help you. And how we do this with three main functionalities. The first one is TCP optimization, which can actively make your network faster. Then we have bandwidth management, which is about lowering the latency and the bandwidth, especially when you can reach congestion. Also, finally, network visibility, which is about letting you see inside your network, see your subscribers, the quality, see the services that are being accessed through your network. You can now also evaluate the service that you're getting, maybe from different network providers. In all this, we deliver in our product is really a software that runs on standard off-the-shelf servers. When you install or if you get it already installed, as we can deliver it to you as an appliance, let's say, we install it somewhere in your network. We'll work with you to see exactly what's the most the best place to deploy it. But when you install our software in a server, it becomes an appliance, and this node can then see all your traffic and actively improve it with its three main functionalities. So now we'll, but as I said, in the US, thanks to Mike, to solutions for EVs, we can also, in many cases, deliver it to you already installed in a server, and so you'll basically be a plug and play thing, and to install it in your network. But in any case, let's go with the three main functions. TCP acceleration. TCP acceleration is about increasing the speed experienced by your network users, which is not the same as the network speed that you make available to them. Because the thing is that the speed they experience, that your users experience, is the speed that the applications they use make use of, or the speed at which, for instance, they get content from the content servers that they use. And that is in many cases is lower than the speed that is actually available. With TCP optimization, what you get is to basically you can avoid this unused capacity, because with TCP optimization we can we can help those applications that they are using and those content servers to actually send at the optimal speeds and use basically the network speed that is available and not leave unused capacity. So why, the question of course is then, why do apps, applications, or content servers leave unused capacity? Why don't they use all the available network speed? Well, the answer is that there's transport protocols are like TCP or QoE. They are the ones, they basically reside on the servers mainly, and they decide at each point at what speed to send to each subscriber, each connection. So the thing is that that's been there since the beginning of internet, and it works very well. That's why internet works to a large extent. The thing is that one of the features that they all share is that when those transport protocols, TCP, QoE, whatever, they think, or they seem to, they think they detect any kind of congestion, then they transmit slower. And that makes sense, because in this way they avoid collapsing the internet. However, the problem is that there are many cases when there's wireless hops in the path, when there's high latency, when there are lossy networks with some network packet losses, then they usually confuse some of those situations with high congestion situations, and then they send at a slower speed. And so that's where we can help, because when you have TCP, which is the most popular transport protocol in the internet, we can act as a transparent TCP proxy in the path, and then basically use with our TCP, avoid those problems and be able to send to your network, to your users at the most optimal speed. And these transparent TCP proxies are nodes, network nodes, that have been widely used for a long time in certain networks, like satellite networks and cellular wireless networks. They've been used for many years. What we have now with our system, we have made now this available to other networks, because in those it was to a large extent a fairly expensive functionality, which only some of those networks that can charge a lot per gigabit or per megabit per second transmitted could afford. Now we have made this available to basically any ISP. And the thing is that when TCP, when the transport protocols are the limiting factor for speed, and that is quite often, then increasing the internet bandwidth won't help. In those situations, and you'll see in many networks, people have performance issues, even when there's no congestion, which means that there's not a problem with the internet the backhaul internet, the capacity towards internet. So in those cases, it is these protocols that are slowing things down, that are the bottleneck. And in these cases, it's only with these kind of systems that you can actually improve speed. And it may be only for certain customers, but it depends, of course, each customer, every situation. But and nowadays, for instance, wireless networks, even if you have a fiber network, in the end, most subscribers in the end will use also Wi-Fi, and Wi-Fi is wireless. So you will experience some of these problems, and in those situations, we can help a lot. So how does it really work as a transparent TCP proxy? So let me show you with this short animation. Let's suppose we have here 2 servers, and this is just an example. And they want to send 7 packets. They'll send like 1, then 2, then 4 different rounds to probe the capacity of the path of the link. And if you have the clients here in this example on the left, when they get one of these each of these rounds okay, then they send this acknowledgement packet saying, I got that. Fine, let me have the next round. Okay, so up here we have the direct path with no TCP proxy, no node like ours, and in bottom we have our node somewhere in between. We'll have this 5 seconds so that we can see the packets, or it would be milliseconds in real scenario. So when you have when we get the first packet of this download, we send this acknowledgement as if we were the final end user. And so when this acknowledgement reaches the server will then send the next round, which we will store in a buffer that we keep for every connection. And now when the real acknowledgement comes from the end user, we already have that second round, so we can already send it out. And here, in this case, for instance, we've gained 4 seconds over the path up here. And the same will happen with the next round. This third round will be ready when this acknowledgement gets to us. So in this case, we got the 7 packets reached the end user in 17 seconds. Up here, it'll be 25 seconds because it will be 8 seconds, 4 more seconds per round, except for the first one. So the key here is this buffer that we keep, where we are able to have the data, the contents up front. Basically, we manage to be 1 or 2 rounds ahead, so that when these acknowledgements get to us, we can already send as if the contents were from always here inside your network. So for the end customer, they see the internet is now closer, because all these servers for them are really much closer. So, and closer means faster. So, and even more so, if you have any kind of packet losses, which may happen very often, if they have Wi-Fi, for instance, then TCP, all these protocols can retransmit those lost packets, no problem. But here we'll be able to send those retransmissions earlier, because we already have them in your network. We are keeping those until they are acknowledged. So, and not only is this an advantage because of this, getting the contents in the internet closer, getting them to your network so that they are served much earlier. There are some cases where we are deployed with basically in the same rack sometimes as some of these content servers, because in some large networks, they may have cache nodes for Google, for Netflix, for the main contents. And then this getting the contents closer is true still, but it's really, we are only making them a few microseconds closer, which would not really have much impact in that sense. But we still can accelerate in a significant way, because we can then make use, well, basically with when we send out those packets, we are using our TCP, which is basically the same, the standard TCP, but we've optimize the algorithm that decides the speed at which data is sent, so that in this thing about sending 1, 2, 4, getting to the optimal speed, detecting the right, the bandwidth available, we will not be fooled, as TCP often is, by random losses that occur in wireless networks or from large delays. From any of those things, we have, our protocol is much better than that. We have some very good patents we've had for quite a few years, and those will basically get us to send at a higher, more optimal speed. And so how we can really measure this. Here we have, our system is already deployed in over 300 nodes in more than 250 customers all around the world. These are 12 of them, very different kinds of ISPs or networks. And some of them are wireless ISPs. There are also some cellular mobile networks. There are fiber networks. There are cable, DOCSIS cable networks. Plus, really, TCP is all the same, of course, in all of them. And we can always help. And how much depends on the network. Because, for instance, if you look here, we are measuring. We just to compare apples with apples. We just analyzed Netflix downloads, not because it has anything special, just because it's all around the world. And we looked at average speed of all TCP, all the Netflix connections, with and without the optimization. And we could measure the connections without optimization, because we leave always a very small percentage, 1% of connections without any optimization. We just let them go through, but we measure them. And in that sense, we can show you the in real time the amount of acceleration that we are providing. And in this case, for instance, if you look at this ISP, for instance, the first one, the wireless ISP, the average was 3.8 megabits per second with optimization, 2 megabits per second without optimization. It's the same network, but it was possible to send at 3.8. We were sending at 3.8, but this was on average, of course, over a week, and very small, large connections. But on average, Netflix was sending at a lower speed than was actually possible. So the same network now looks, feels, and looks for the end user is a faster network. And so the end result of all this is, for instance, like, for instance, this success story, one of our customers in South Africa, who was telling us that this is Interworks, and they were telling us that since deploying our node, the amount of support calls complaining about low speed test or buffering with streaming went down a lot. So basically, they have a much happier customer base. Plus, of course, the savings that come from fewer support calls. So the next functionality is bandwidth management. Okay, so we can offer you, while TCP optimization is something that you will not get from many vendors, bandwidth management is something that you can get from other vendors. So what makes us different? First, that our bandwidth management is very flexible. You can do very sophisticated schemes for managing the bandwidth in your network. You can, for instance, have different, of course, you can have different speed plans for different subscribers, depending on what they're paying and all that. But you can adapt that. For instance, you can have different policies for maybe fiber subscribers or radio subscribers. You can also have different policies that will apply when your network is near congestion or not getting close to congestion. So depending on the speed that your throughput that your network is experiencing. So sometimes it may make sense, for instance, when you, when your network is close to congestion, some certain kinds of contents, which we can differentiate with our deep packet inspection, with our DPI, for instance, apply maybe some throttling of video streaming for which but only in those cases, just to maybe when you're the whole network is getting close to congestion, maybe you want to make sure that everybody gets, for instance, full HD, but you don't get a few subscribers getting 4K, which may impact the rest of the customer base. Well, you decide, in fact, maybe you can have different rules for different kind of subscribers. So the thing is that we give you the flexibility and the control with our software. So as I said, the speed limits can be per user rate plan, per application DPI, network throughput, source and destination IP address, VLAN tag, interface, many others. We are also now allowing in a few versions coming up, different times of the day, different times, for instance, access points, different, a lot of, you have a lot of flexibility, and we encourage you to try that. Also, the next thing is it's also very efficient and economical. We can manage to get up to 150 gigabits per second with our functionality in one single server. And server that well, the hardware can be around maybe 150 gigabits per second from 20 or 30,000 US dollars server. Of course, that you can get also 10 gigabits from a server that's I think it's 1700. So you have all the well, from basically 1 gigabit to 150 gigabits, but you can have a more centralized management than if you're using, for instance, many PPPoE servers or other nodes to enforce the speed plans. So the thing is that if you use us, the PPPoE servers or the OLTs or whatever nodes you're using for, and now for this queue management, for all this, basically you'll reduce the CPU tremendously in those nodes, because when we can do this very efficiently, but most of nodes out there don't do this very efficiently. So you can then reduce the CPU they use and then have either fewer of them, because you don't need maybe as many to do the same amount of all these, to enforce all the rate plans, or they can also be used for other functions. So we can also limit the speed with so we have flexibility. This is a more centralized, more economical, and then also the other differentiating feature is that we think we can deliver the best quality, while the best quality of service, while enforcing all this bandwidth management. Because, well, basically, if you enforce any kind of speed limit or you have any kind of congestion, you have one node basically where packets are getting in faster than they are going out. And so there has to be some kind of buffer or queue, which ends up filling up. And that means that there's latency because packets have to wait since they get in until they get out. And in some cases, even packet losses. So in principle, there should be, of course, some kind of quality degradation. The thing is that we think that that may not be the case in many. You don't need to have that quality of degradation, that quality degradation. Basically, we can. The thing is that if in congestion or if there's a speed limit, basically the heavy flows like streaming, software downloads, they basically, of course, they go slower, somewhat slower when there's this speed limitation, but they adapt themselves quite well, and they have a huge caches. They have the buffers. Netflix, for instance, has a 2-minute buffer. They can adapt themselves quite well to these situations. They'll just use maybe a slightly lower, lower resolution, but they'll manage fine. However, it is really interactive flows like online gaming or teleconference that suffer when there's congestion or when there's a speed limitation. These latencies, these possible packet losses are really very bad. The good thing is that those interactive flows are usually not the ones that have the heaviest traffic. So we can play with that, and we can enforce all these speed limitations without impacting the interactive flows. And so how do we do this? Let's basically, the key is that we provide one queue per connection. And that means may mean a lot of queues, because for instance, one subscriber may have at any point 200, 1,000 connections. No problem for us. We basically, our software is designed so that we, for instance, have nodes where we have millions of connections, simultaneous connections. For us, because of the way we've developed it, it's not a problem. It's just about the number of packets that matters to us. The other thing is that we can provide enforced priority for interactive flows, for the queues that hold the interactive flows versus the ones that are not interactive. And so how do we do this? Let's show you. Let's have here, as an example, what would happen with some data that coming from internet here on the right, going to the client, which is limited in speed to the left. And so up here you'll have the implementation that many other systems will have, with not using one queue per connection. We'll have here just one queue. Others may have a limited number of queues, but the difference with us is that we have one per connection, no sharing at all. Because always when you share, you end up getting one packets that are interactive sharing with a queue with packets that are heavy flows, and then the interactive ones have to wait for the others. And so, so the thing is that, for instance, let's imagine this is the first packet that comes from internet, and it's a YouTube packet. So in both cases, they'll be stored in a queue. Okay. So far we're working the same way. Okay, so we're storing packets as they come. Now, the first difference is when there's a packet, for instance, for a different connection. Maybe this is a Netflix one. So we put it in a different flow, in a different queue, sorry. But so far it's not a big difference, because they are just getting stored. So now at some point, it's time, of course, to let packets flow to the client. It's limitation, but not blocking. So here's the initial difference. We will now share the bandwidth equally between basically connections at all the different queues. So that's an initial advantage, because in this situation, the heavy flows will not overwhelm others, because we will share equally between different outstanding flows, connections. So that's an initial advantage. They will keep, as some kind of a round robin policy, sharing the available bandwidth between existing queues. Now, but the big difference is for when, for instance, this packet comes, and it's let's imagine the Zoom packet, it gets its own connection, its own queue. Okay, so here it would only have to basically now it would only have to wait, for instance, one more turn for the red ones, and then it would be the turn for Zoom. But we even have this priority scheme, so that we detect that it is a fairly easy algorithm. We detect that it is an interactive flow, and it even jumps that queue and basically gets the next turn. So for this packet, this is as if there was no limitation, because this packet came and went directly. So we have, but for instance, in this other case, it would have 10 packets to go. So big difference here, thanks to our, so the quality in the end will be much better, because yeah, of course, in both cases, the Netflix or YouTube will be, well, they will be slower, but here the interactive connections will not get but will not, in many cases, even notice there is this congestion. So we also can do more to reduce even the heavy flows, the heavy queues. We can do so that, for instance, in the TCP ones, because we are a TCP proxy, with the window, there's a window parameter in those acknowledgements that I showed before. And with that, we can actually tell the server, at what speed to send to us. So by getting the server to send at the speed that we wanted, basically it will be sending, we will be getting the packets at the same speed that they are leaving us. So if you get the server to send at the same speed as they are getting out, you basically build much less of a queue, because a smaller queue, because queues build up when servers send faster. For UDP, we cannot do that. I'm afraid nobody can. It's a really encrypted, so we still do the best that you can do, active queue management, Codel, but it's not, of course, as good as what you can do with TCP, but it's quite good. And we use that, okay? And so, and basically, we really think that this is the best solution in the market. It's better than simple queues. It's better than stochastic fair queues, per connection queues, FQ Codel. This is much better because of all the TCP enhancements, and really FQ Codel does share queues. That's the point. Cake is also inferior to this solution. And we just encourage you to try it out. It's this is one of the things that is the easiest to send. Just get one of your subscribers in congestion, have it do it with us with another system, and just, for instance, have at that point with the other three Netflix or 3 YouTube flows at the same time, and get at the same time something interactive, or even a simple persistent ping, which tells you about the latency and the losses, and you'll see the results. So now, when you have to integrate this, we are also quite good. We can either work with one of the things, of course, is how to get to us the information about which subscribers have to get which policy. And you can do that in different ways. You can we have a graphical interface. You can do that easily there. You can also use scripts, or we can even do that automatically if you have any kind of a radius. If you're using radius in your network, we can program, for instance, if you have a MikroTik PPPoE servers, we can get them to send copies of the radius accounting messages to us. It's very simple. It doesn't affect what they have to do, what they are doing. And they are talking to your subscriber management system, radius server, and they just send us copies. And in those copies, there's the information about this IP address gets this policy. Or even the policy itself, it's many times there, and we can just get those parameters and then start applying that profile, those these limitations, uplink, downlink, burst, all those things. So it's really easy to integrate if you're using Radius, or it's also easy, as Mike was saying before, that we have a REST API, and so you can basically have a program that gets the information from your management system or from whatever, and inputs it to our system, and you can program our system through this REST API in real time. And we are developing, we don't have right now, we're starting to develop some hooks to the main billing system so that it'll be even easier. So the end result is, if you measure the latency, which we do for all the network, for instance, basically the average, this is the latency for the whole network, the average, it goes down when you start using our system, as opposed to be using other system at a certain time. This is when they switched in one network from one to the other, there was a significant reduction in latency. Or you can also see the results if you do some fancy, like for instance, some limitations on shaping of video streaming with our DPI, just when you get to congestion in your network, because you have maybe some problems at the time. And so when you do that, basically you will see the peak bandwidth, the throughput on your network go down from anywhere from 10 to 20%. And in fact, there won't be a quality impact. In fact, the average quality of the network will actually normally go up, because when you reduce the peak throughput, the peak bandwidth, then usually the latency also goes down, because some of these streaming applications, they really can clog networks at peak time. So this is something we are working on. We're launching very soon about this machine learning based, AI based detection system. Basically, we detect sometimes you may have a 10 megabits per second plan, but maybe in the backhaul or whatever, there's a 8 megabit per second limitation. So we can detect those limits below what the actual, well, the nominal rate plan. And if we detect them, then we enforce a limit somewhat a little below. Like if it is, we detect 8 megabits, we will enforce it at 7.5, something between 7.5 and 8. Because when you do that, in fact, the quality goes up by a lot, because when you actually reach congestion, latencies and packet losses go up exponentially. And if you manage to avoid that, just being a little slower, the quality will actually be much better. So we've seen in early trials how this reduces the peak latency in some networks, not as much as when you actually do you actually get the reduction that you get when you actually input and we do the rate limitation. But basically, a success story, for instance, we have here is and this is a large customer in Honduras. Basically, they are using our system to do their rate plans, and basically they saw a very significant reduction of latency, and also they reduced the cost because they were using a lot of PPPoE servers. And if you just add up how much those systems cost, those 72 core routers, if you have and compare with the price of our system, it's actually a reduction in cost, and a significant one. So they got better quality at lower cost. So that's the second functionality. We do all these things integrate in an integrated way. Sometimes you may be interested in one feature more than others. You get all of them in different times. Some may be more useful to you, but this is the final the network visibility stuff. This is about basically showing you, for instance, initially with our deep packet inspection, what the amount of traffic you get, for instance, how much YouTube or Netflix or Facebook you have at different points. This is 3 days of traffic in one network. Okay, and so you can see how much YouTube. This can help you plan your peering. See, well, basically, it can be very, very useful to actually know what you are carrying on in your network. And not only that, you can also now go, for instance, to one of your the services, for instance, Apple. And so you can see that the services from Apple are coming in this network mainly from servers that are from 20 to 30 to 35 milliseconds. So you can actually see, and you can compare these for different, maybe you're getting your internet from 2 service providers. So you can actually now see if you're getting it, how far it's coming from different providers, which it can also help you measure the quality that you're getting. And not only that, you can even see it over time. For instance, in this network, these are 3 days of traffic in the network. But what we are seeing here, for instance, in blue is when it's traffic coming from 0 to 10 milliseconds. So normally it's coming from 0 to 10 milliseconds, but during those times, which is really at night, looks like it's mainly coming from 20 to 30. So this is, for instance, in this network, this was because they at night, many of these systems with this automatic, software updates were kicking in. And then those, for instance, from Apple and others were coming from further away. So you can actually see over time at different times of the day where you're getting the contents from. Sometimes it can help you if you have cache networks. You can see when they are actually pulling the traffic into your network and help you plan better. Apart from planning and or also evaluate the service that you're getting from different service providers. You can also see, for instance, the top subscribers, the 20 or 30 subscribers that are using your network the most, and see the profile, what they are actually doing. Because sometimes you may have some that are using your network at full speed all the time. So sometimes there's a problem there. Okay. And finally, then you have all these metrics to actually see and measure the quality, the visibility of your subscribers. For instance, of course, you get the usage, how much the usage, the usage every day. In fact, for 3 months, you get them. This is versus one subscriber, how it's this subscriber is using your network over a week. Okay, but up, down, well, different, all those things you get. And then, but you can also see, we also measure the maximum speed they are getting, because it's not the same thing. Of course, they may have for instance, this guy it looks like it's getting up to 39 megabits per second, which is quite all right, because I mean, they may have the 40 megabits plan, but they don't always use it. This is just how much the maximum we measure over a certain window of time. And so but if you, for instance, if it's a 40 megabits per second plan, then it's quite all right. But if it was a 50 megabits per second, then maybe there's a problem, because this guy is never getting the speed that that should get. So you can then go and analyze why with our system. But for instance, we also have measurements, real-time measurements all the time for 3 months, as again, for latency, the latency from our system to each of those. So basically the latency in your network. And so there you can see that this guy, for instance, here in darker blue, is getting around 2 milliseconds. And actually you also get to compare the whole network. Soon you will also be able to compare against the same access point, the different, or the same PPE server, different classification points. But in the end, you can actually see that this, for instance, comparing with others, this is not probably a problem. In fact, it's a pretty good situation. So then you can look at, for instance, retransmissions, which we can measure, which are indication of packet losses, of course. And so you can then see that this guy, for instance, is getting much higher retransmissions, 7%, compared to the average of the network, which is around 2%. So maybe this is the problem, that this is why this subscriber is not reaching the maximum. And you can also see things like, for example, the amount, how many flows are started every minute or whatever. And so you can sometimes also diagnose problems like someone having some kind of serving lots of subscribers in that network, or maybe having a virus, or being used to perform denial of service attacks. Even though for that, we actually have some detection of different denial of service attacks. For SIM floods, we can detect coming out of your network or getting into your network. And also volumetric attacks. So we can also tell you about that and tell you which network is, which IP addresses are attacking you, so that you can, you can take measures against those, or sometimes know which of your users is producing those attacks, because maybe it's a virus or whatever, but maybe you can get your network banned, the IP addresses in your network banned, and so you don't want that. And for instance, this is one of our customers, Victor Lewis, in the CEO of Wi-Fi Canarias. He's basically saying that with this functionality, the DPI, the subscriber visibility, he has a very important tool, a very useful tool to actually see what's happening in his network. And when he has complaints, which many times are very fuzzy, there's just this is slow, or I can't work well, he can actually see with numbers what may be happening, and point to allow him to analyze the subscriber traffic and solve see what's the problem and solve the issue. So our system, as I said, is we have over 300 nodes worldwide, all the American continent from Canada to Chile, and also lots in South Africa and Europe, and we're starting also in Asia. It's over 250 customers, just that some of them have more than one system. Deploying this system is actually quite easy, because we work at level 2. It's like a bridge switch. Everything that comes in gets to the other side with no IP addressing required. Well, it actually can be many links. It can be several links. You can actually, for instance, run an aggregate link transparently through us. And there's another port for management with an IP address, where you can actually configure or see all the graphs and the results. And you can also, if you like, we can help you set up a bypass link in case there are any problems, how to avoid impacting your network. About recommended hardware, we usually work with Supermicro servers, and Mike, in many cases, can provide them to you also, so that basically what you get, as I was saying at the beginning, is an appliance ready to go. And even if you tell us your IP address, it'll already be configured. It's really plug and play. But if you like, if you prefer, we can also use servers that you may have available, or you can also use virtual environments, VMware or KVM. How much the hardware you may need depends on the how much throughput you has to go through. It can be anywhere from 1 gigabit per second to 150 gigabits per second. It's really, we don't really need, it's very efficient. We don't need a lot of hardware. For instance, for a 10 gig system, it'll be quite fairly inexpensive thing, around $1,700 US dollars server. So how do we work? We always offer you, we are saying we can do great things. So we let you try them out for free. We offer you a free trial, which includes free deployment support. We help you get it up and running. We help you analyze, getting it installed, getting it we analyze the results for you, and then after a couple of weeks, this trial, we then basically talk with you, and if you see, if you see we can give you all the value that we say we can, then you can get the system for either as a monthly subscription or a one-off perpetual license. And it's a pay-as-you-grow. You basically pay depending on the amount of throughput per gigabits per second. For instance, these are the pricing, the monthly charges. For instance, for 1 gigabit per second, it's $300 US dollars. If you have, for instance, when you can notice that, for instance, for 10 gigabits per second, it's 1,300 US dollars. It's really, if you look at how many subscribers, really a few cents per subscriber per month. And you get with that, but on top of that, there's this the hardware. It's the price of it's actually less than the 1,700 I was saying. But all this you can discuss with Mike with Solutions for a Business. You also can buy this perpetual license if you prefer. Then it's this price. These are from 5,000. Around 5,000 for 1 gigabits per second, or 10 gigabits would be 23,000 US dollars. And on top of that is the hardware. If you already have hardware, then you can use that. Okay. Oh, the support is included for the first year. In this case, in the monthly subscription, it's always included, of course. In this other case, with the perpetual license, then you pay 10% every year after the first one. And so basically, this is the set. I don't know if you have any questions, Mike. If there are any questions we can answer.
Yes. Let me bring them up here. First question is: will your solution improve speed test results? Can you provide more priority or bursts for speed tests?
Yes. Our deep packet inspection can detect speed test, and you can apply a different profile or for speed test or prioritize it. Mm-hmm.
Okay. All right. The second question is: does your product optimize IPv6 and as well encrypted traffic?
Yes, IPv6 is supported, and data path and encrypted traffic. Yes, but most of the traffic today nowadays is in fact encrypted. So yeah, TCP is below the encryption. Usually, it's encryption is TLS, and that goes on top of the TCP. We can also see in quick, for instance, in UDP, we can also look inside just the domains, and from that find for the deep packet inspection what the application type. And we don't see the contents themselves, just what applications they belong to.
Okay. How does your product improve the online gaming experience?
The online gaming experience is improved when there are latency issues in your network. If, for instance, when you are reaching peak times, you're reaching congestion, those congestion, if that congestion is causing some latency issues, then we can help you in those situations and improve in a significant way the quality those online gaming users are getting at those times. So it's by reducing the latency.
Okay. Is your software compatible with all all core and radio vendors?
Yeah, we are basically agnostic about that. It's just basically we work transparently in level 2, so we just have to be in the path. It can be before, after, different nodes. We can work with you with different networks to see what's the optimal place to deploy it.
Okay. Apart from video streaming, can you limit point-to-point traffic?
Peer-to-peer, you mean?
I'm sorry, yeah, peer-to-peer.
Yeah, we can detect some of the peer-to-peer, the BitTorrent, and so we can apply some limitations there. Yeah, sure. It's true that peer-to-peer is more, they keeps changing, so it's not as good as the detection we do, but it's for overall for the network is quite good. Yeah.
Okay. Well, the last question is for me. It's do you provide the server for the free demo? Yes, I can provide a server for the free demo. We're short supply right now, but we do have a few. The only requirement is that we get a credit card number from you in case you decide not to return it or want to keep it. So that's the only stipulation. But if you try it and you don't like it, I won't don't charge the credit card, and you just send it back in the original box. So it's a no commitment trial, and no reason not to do a demo, in my opinion. But that's entirely up to you, the buyers. So okay, well. I think that basically that's a wrap. That's all the questions. Jose, thanks for going through everything. I again would just say to everybody that the product from a visibility perspective has improved dramatically. I think that's a feature that even if you don't want to do the control, it's well worth knowing what is going on. This product also it's not really a competitor to Preseam if you have Preseam. In my opinion, you can run both. I have customers running both. And it, what I see Preseam do is that they control, they give you visibility into the overall network, your access points, your towers, whereas Bequant focuses on what the individual is doing and trying to control that person. And so it's a very good product for helping you resolve what's going on. As well, the DDoS stuff is very expensive, and that you're buying or can buy, and I think that's a feature that is there in Bequant that is kind of often overlooked in terms of value. So having said all that, Jose, do you have anything else you want to add, or we can conclude?
No, just encourage people to try it out, and we'll be there looking forward to working with them. So
okay, all right, thank you, everybody.
Okay, thanks a lot, Mike, and thanks to all the attendees.